Task number 8, Common Shell Payloads. This task is part of the What the Shell module, which is a prerequisite of the module Upload Vulnerabilities inside the complete beginner path on TryHackMe. So task number 8, Common Shell Payloads. We'll soon be looking at generating payloads with MSF Venom, but before we do that, let's take a look at some common payloads using the tools we've already covered. So we covered Netcat and Socat. A previous task mentioned that we'd be looking at some ways to use Netcat as a listener for a bind shell, so we'll start with that. In some versions of Netcat, including the Netcat executable, the Windows version, including the Kali version, and here it shows where it is, and the version used in Kali itself, the Netcat traditional, there is a -e option which allows you to execute a process on connection, for example as a listener. Here we see that this is the command, this part is the first command that we saw already, and this one is the new one, the new part that it's added with -e, and after we have the connection, we are accessing bash basically. Connecting to above listener with Netcat would result in a bind shell on the target. Equally for a reverse shell, connect back with the same command. It's the same command minus this one, right? Because we are not opening a listener, we are connecting to one. We have a reverse shell, right? Would result in a reverse shell on the target. However, this is not included in most versions of Netcat as it is widely seen to be very insecure. Funny that, eh? On Windows, where a static binary is nearly always required anyway, this technique will work perfectly. On Linux, however, we would instead use this code to create a listener for a bind shell. This is the entire command. The following paragraph is the technical explanation for this command. It's slightly above the level of this room, so don't worry. If it doesn't make much sense for now, the command itself is what matters. The command first creates a named pipe at temporary F, right, in this directory. It then starts a Netcat listener, the next command, and connects the input of the listener to the output of the named file. Here. The output of the Netcat listener, that is the commands we send, then gets piped directly into shell, sending the ctderr output stream into ctd out, and sending standard output itself into the input of the named pipe, thus completing the circle here. And here we have an example, attacking machine on the left, vulnerable machine to the right. We have two whoami's to display the current user, and here we see the reverse shell. This is the command that we saw already on the attacking machine, and here we see the attacker machine running the connection. A very similar command can be used to send a Netcat reverse shell, and here the bind shell is complete. We are shell. This command is virtually identical to the previous one, other than using the Netcat connect syntax as opposed to the Netcat listen syntax, right? So here we have the command from above, but instead of listening, we have connecting, right? And this will do a reverse shell, right? Attacker machine on the left, the vulnerable machine to the right. A whoami command just to see the current user, and then a listener. Here on our attacking machine, we open the listener, and on the vulnerable machine, we just use the entire command that we see over here. When targeting a modern Windows server, it is very common to require a PowerShell reverse shell. So we'll be covering the standard one-liner PCH reverse shell here. This command is very convoluted, so for the sake of simplicity, it will not be explained directly here. It is, however, an extremely useful one-liner to keep on hand. And here we see the entire thing. I don't think, and I don't remember ever seeing a bigger command than this, a longer one. This is the longest command that I saw ever. Like, it's crazy. It's crazy. So in order to understand this, you can go to ChatGPT, copy this, paste it in ChatGPT, and just ask him to explain, simply explain what each flag and command does. That way you will find everything. You will understand everything. In order to use this, we need to replace the IP and the port, which we can see here and here, with an appropriate IP and choice of port. It can then be copied into a command executable shell or another method of executing commands on a Windows server, such as a web shell, and execute the result in a reverse shell. So this entire command has to be copied into a command executable shell. Here we see an example. Right, we open a port, then we have a remote desktop protocol session, and here we see that entire command. And from that, we also can see, after we run the command, we can see that we are inside a Windows computer from a Linux operating system. For other common reverse shell payloads are the things, the GitHub repo, which we know already. It's pretty amazing. It's a repo containing a wide range of shell codes, usually one-liner format for copying and pasting in many different languages. It is well worth reading through the linked page to see what's available. Answer the questions below. What command can be used to create a name pipe in Linux? This one. Look through the linked payloads of all things reverse shell cheat sheet. All right, let's just go there really quickly and familiarize yourself with the languages available. Complete. We can see here the reverse shells. Also, we can see here for PowerShell, look at this. Load PowerShell scripts, constrained modes, right? We have bind shells, active directory attacks, containers for Kubernetes pen tests. It's just a very, very useful tool that we can use. Meterpreter shells, Spawn TTI shells. Here are the languages: PHP, Perl, Java, Dart, C, Bash, Python, Ruby. Let's go for Rust and C. There you go. Boom, straight to the point. Boom, use this. Boom, you have a reverse shell.